Mm. Good morning, students. How are you guys today? Sorry, I was just finishing up my last sip of coffee. I hope you guys have been following up with the last videos. And so, in the previous video, as we were discussing the three different ways to present the domain and range, today we will be discussing a few different examples. Where we have to find the domain of the following functions. So it's always good to solve some examples for a better understanding. So the first example is we have f of x is equal to x squared minus 1. Now we need to find the domain. Now, who watched the previous video? That person. When I say domain, the first thing that should come in your mind is the input values, the possible input values, I'm sorry. So if we look at this function, guys, is there any x value which we cannot use? Think about it. Like I can even use 0, I can use a number as large as infinity, I can use a number as small as negative infinity, right? So here the answer is simply the domain is, let me use interval notation in this example, from negative infinity to positive infinity. Okay, so I use interval notation in this. I could even use another notation, for example set builder notation. So I can say that x is such that it's greater than negative infinity, smaller than positive infinity. Now you know the rule in mathematics that the endpoints, when negative infinity or positive infinity is an endpoint, it is never included. Hence, it's not greater than equal to, it's not smaller than equal to. It's only greater than here and it's smaller than here. Okay? Let's move on to the next example. You have f of x, let me do it here, is equal to x plus 1 over 2 minus x. Okay, think about it, guys. Whenever you have a fraction generally, for example a over b, the only time when this fraction is undefined or will not give you any output is when b is equal to 0. Am I right? So b cannot be equal to 0, right? So let's relate that concept here. Let me erase that one. Similarly, what is the denominator here? 2 minus x, right? So can I say that 2 minus x is not equal to 0? Definitely I can, right? We don't have any problem with the numerator, but the problem is with the denominator. Depending on whether denominator is 0 or not, it will or it will not give us an output. So can I say now that x is not equal to 2? Because when x is 2, the denominator becomes 0, and x plus 1 over 0 will give us undefined. I hope that is clear. Now the short way to write this, here, see, here's where the three ways come into benefit. The shortest way to write this is in set builder. Why? Because I can write that x is such that x is not equal to 2. This eventually means that x equals to every value except 2. If I write the same thing in interval notation, this is how it looks like. So x can start from negative infinity until 2. Now 2 is included or not? No, right? 2 is not included. So we use a normal bracket. Union, again, above 2 all the values are included, right? So we write 2 up to positive infinity. You see how big of a hassle this was? So might as well use the set builder notation. Now let's look at the third example. We have f of x is equal to square root of 7 minus x. And let me make a line here so that we know this is a different example. Okay? This is a different example. Okay? Square root of 7 minus x. Now what is one condition whenever we have an even root? We know that the value inside the radicand, I'm sorry, cannot be negative. Means that this 7 minus x should always be greater than or equal to 1. So let me write it. So 7 minus x can be greater than or equal to 0, right? 0 and above. So let's solve the inequality. So x is smaller than equal to 7. All values smaller than 7 can be used in this function. So for example, even if you use x as 0, it's going to give you a 7 here. Even if you use x as negative 1, now negative will become a positive. It will become 7 plus 1, 8, and so on. Okay, so I hope that is clear. Now, I believe I do not need to erase anything. Let's solve the last example here. We have f of x is equal to minus 1 over square root of x. Now, we have a problem here. The problem is that not only we have a square root, the other problem is that the variable is in the denominator again. Now the denominator cannot be 0. Okay? Generally, if this was a square root, it could be x is greater than equal to 0, right? But the problem is when the variable is in the denominator, how do we solve this one? So let's set the conditions. So the first condition is that x should be greater than, okay, or equal to 0. Speaking about this alone. But when we see that the variable is in the denominator, now we have to exclude the 0. So x cannot be 0, right? Why? Because square root of x cannot be 0 eventually. I mean, this is what I mean. Square root of x cannot be 0. And hence, x cannot be 0. So, means that x can take all values above 0 this time. Why? Because the variable is in the denominator again. So, x is greater than 0. This would be our domain. Now again, let me write it in interval notation. So it starts from 0 and then it goes all the way to infinity. Okay, 0 is not included, hence I'm using a normal bracket. If 0 was included, I would be using a square bracket. I hope this is enough for today, guys, and make sure you understand these things, because in the next video I'm going to be moving on to some different kinds of functions, and I might discuss some more complicated examples on domain and range. Thank you so much, guys.